What are we gonna do? What are we working on tonight?
More SAT prep. Last time we worked on practice test number 2.
Yeah, I remember. Let me open that up and find out where we left off. You sure we were on 2? How many times? Oh, we might have started on 2, but yep, you're right. I got us on test number 2, number 9.
Yes, that is what I have as well.
Okay, well, let's have a look at that. So, do you have a practice booklet, a workbook that has practice tests in it and stuff?
Not an entire booklet. I have one from the NMSQT that is partially, I did one of the 2 practice tests in there.
Okay. I think that's probably a key part of preparing for the test is to do as many practice tests as you can. And if you go to the library, you'll find 4 or 5 different books. There's a Barron's, there's a McGraw-Hill, there's Princeton Review. Any of them will have 2 or 3 practice tests in it.
Okay.
And that's what I would suggest as a way to just do it, or as a way to work on it when we're not doing practice tests.
Okay, sounds good. Also, do you recommend the Khan Academy practice that you can link to your College Board account?
I'm not familiar with it, but
Okay.
I'm a huge fan of Khan Academy. So
All right.
I would say that anything they do is probably very worthwhile.
Sounds good.
All right. I do not remember doing number 9. So I wrote number 9 on there, but I think probably that was what I meant was 9 was the next thing to do. Do you remember doing number 9?
Yes, I do have number 9 in my notes.
Okay. Well, let's start on number 10 then. All right, here, let me blow this up a little bit so we have some room to write. Okay, which of the following equations has a graph in the xy plane for which y is always greater than or equal to minus 1?
Okay.
How about we try graphing each of these? That's what I would do, because now I am very familiar with graphing functions and transformations of functions.
Yes.
So I can graph these pretty quickly. Are you also pretty good at that?
Yeah, I'm pretty good at that. We just did a unit on parent functions in pre.
Great. So if we look at the first one, we know y equal absolute value x minus 2. It's going to look like that. And obviously, we have a value at minus 2 for y. So that's not it. There might be a better way to do this, but usually when you have a problem like this, just going through each one, especially if you're good at graphing them, and it doesn't take you too long to graph them. It's a parabola shifted down by 2 units.
Yep.
It also has values less than -1, so that is not correct. X minus 2 squared. That's a parabola where? Where's the vertex of that one?
It would be at +2, 0.
Beautiful. That is a choice, right?
Yes.
In other words, every y value there is greater than or equal to -1. Now, the question is are we done with the problem or do we have to do more? Do we need to check D?
No, because there's only one correct answer.
There will never be two correct answers. So once you've found one correct, don't waste time doing that one. And that's one of the things we teach in our seminars is that do not spend time checking answers. You're going to not have enough time. This one looks like something like that. And that's got all kinds of y values that are less than -1. But the key thing is we discovered a correct answer, you go with it.
Okay. Makes sense.
Let me go up to 11. First of all, what do we do with complex numbers where you have division involved?
You multiply by the conjugate.
Great. That's exactly right. So I'm going to multiply that by what?
By 8 minus 2i.
Well, not quite. We're going to, in other words, I can only multiply a fraction by the number 1.
Oh, yes, so 8 minus 2i over 8 minus 2i.
Exactly. You can always multiply any fraction by the number 1, and that's a good thing to keep in mind. Now, what happens to the bottom? Let's deal with it first, because it's the easiest.
Okay, so you have 8 times 8, which is 64, and then you get minus 2i plus 2i, which cancels out, and then you're left with 4i squared, and I squared is equal to -1, so it's plus 4, you're adding 4, and then you get 68.
Okay, great. Now let's do the numerator. You got to FOIL those. Minus 40i minus 6i looks like minus 46i. Now we have plus 10i squared, which is minus 10. And that gives us, if I make a mistake here, feel free to point it out.
Okay, looks good.
Now, so far, I'll bet that's not an answer, but you can tell that that can be simplified because every number is an even number. So at a minimum, I can divide everything by 2. And that still isn't an answer because we have 7 minus 23i all over 34. But always know that when you have a single entity in the denominator, you can always split it up into 2 fractions. You have that fraction there minus this fraction here, and that is that answer right there.
Perfect.
And they probably almost will never give you something that isn't simplified. I would be shocked if they ever had 14 minus 46 over 68. Just because it's kind of the rules of mathematics that you simplify stuff. Although I will add something to that statement. You're familiar with the grid-in portion of this test?
Yes.
You can answer a grid-in question with that answer. Yeah, odd. In other words, you have only 4 spaces, and you can definitely do 6 divided. Well, I guess you can do it in most any order. You could do it like that, leaving a space at the first part.
Yeah.
In other words, you do not have to reduce that to 3/4. However, if the answer was 12 over 16, the same fraction, you only have 4 spaces. You can't put 12 over 16 in there. So sometimes you do have to reduce it. You have to always reduce your fractions to at least something that you can put in 4 spaces. It's all the room you have. You could convert that to a decimal, but you could also just reduce it to 6/8 and put that in there, and that works. Or 3/4. I'm always a bit surprised that they allow you to do that.
Yeah, it's kind of strange.
Yeah, it is a little strange. All right. This is a fairly straightforward algebra problem. You can almost tell immediately that what they're going to ask you to do is solve this for either f or n. And then you look at your answers. Clearly, everything is being solved for f. So, we can ignore all this. I didn't even read any of that. I don't have to. What they are clearly asking you to do there by looking at the problem and looking at each answer is solve it for f. That's all. So you almost don't even need to read this paragraph. Let's solve that for f over here on the left. Let's go through it step by step. It's the first step.
Okay, so I would multiply both sides by 1 over n plus f to get f on its own.
Okay, I think you actually meant this. You're not really multiplying by 1 over.
Oh, okay, yeah.
Okay? Because that's going to get that, rid of that, and that. In other words, when you're solving algebra equations, you want to get rid of denominators. Okay? And now, if you distribute the left side, you have nr plus fr, and on the right side, you have f. Now what? Because now I do need to look at the problem and realize that they're trying to solve for f. Didn't really need to read the paragraph to know that, as all I needed to do was look at all 4 answers. They're all f equals something. So how do I solve this for f?
Let's see.
It's a little tricky. Remember the term gather like terms.
Okay, so then.
Now there's these 2 terms on the left side are like terms. They both have an r in them. But you're not
Yeah.
trying to solve for R. You're trying to solve for F. So you want to, the like terms you want to gather together are the F's.
So then, would you
think, add, and subtract. In other words, all these answers have. So I'm going to move the F that's on the right over to the left. And I'm going to move anything that doesn't have F to the right. Okay, do you see what I did?
Okay.
Now, what can I do? Remember, I'm trying to solve for F.
So then you would want to divide by R?
Factor.
Oh.
What? What would you factor?
Oh. So on the left side, I would factor an F out. So to give you F times R minus 1.
Now, notice we can solve for F. In other words, the only F we have left is this one right there. So if I divide both sides by R minus 1, that's going to be my answer. Now, you'll notice that that's not on there. There's another way to express what I have circled. And this is not always clear either. Let me do it like this. What's the relationship between these two things? What is that equal to? Always. No matter what y is and no matter what x is, that is always minus 1. In other words, a minus b over b minus a is minus 1.
Okay.
So, which answer is the correct answer? It's not exactly what I have circled, but it's very close. First of all, we can rule out these two. They don't have an NR in the numerator. But the other two have a positive NR in the numerator, or RN.
So then would it be B?
Did you say B?
Yes.
Yes. In other words, if I want to change this to have a positive numerator, so all I got to do is switch the denominator. Now that is the negative of that. Two negatives make a positive. So you end up with that. So again, this is a fabulous problem because it has like 4 different parts of algebra to it that are each very, very important to know. Getting rid of denominators, that first step. Gathering not just like terms, but the term that we're trying to solve for, which was F. So you gather all the F terms together. And then you factors. So there's factoring involved. But perhaps the toughest step is this one, the last one, where most people are not particularly familiar with that is always minus 1. You know how you got problems like this when you're doing algebra and it's being multiplied by x plus 3 times x plus 7. It's being all divided by x minus 2. Remember problems like this?
Yeah.
Well, you could cross that off with that. You could cross that off with that. And the answer was x plus 7. Okay? And the general rule was that you could only cross off stuff that was exactly the same. But there is one exception. And that is if you have x minus 2 and you have 2 minus x. Those are not exactly the same. But I know that that's always minus 1. So you can cross them off and replace them with a negative sign instead of a 1.
Okay.
Okay, and you may run into problems like that. In other words, where you reduce everything by crossing off everything that is the same, and you're left with something like that, well, you can do something with that. So this is the only situation I know of where it doesn't have to be exactly the same to cross it off.
Okay.
Where you have a minus b over b minus a. All right, let's see. These are all no calculator still. And now we're getting into some of the harder ones. We would expect these to be a little harder. But I should add that level or degree of difficulty is based on a national average. So it isn't necessarily the same for you.
Okay.
You may be super at algebra and lousy at geometry. And so for you, an algebra problem might be, a hard algebra problem might be about the same as a medium or an easy geometry problem. So always consider that. In other words, don't assume that it's beyond your expertise just because we're getting up there in the higher numbers. Okay?
All right.
Now, this is simple enough. This is a quadratic. If we can factor, or I should say, if we can solve that, and then we just sum the two values together, and we're going to get one of these four numbers. So this is actually a pretty easy problem.
Yeah.
What's another way to do this problem?
So I tried to factor it, but I saw that it didn't factor, so you can use the quadratic formula.
Okay. Hold on 1 minute. You're right. It does not factor. I was just doing it in my head. So you could use the quadratic formula. Do you know it?
Yes. It's x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, good. I'm glad this came up because you do need to know this. There will be at least one question that you have to know this on. However, let's say you didn't know this. What's another way to do this problem? I apologize. No, this is not a good back-solving problem.
Okay.
In other words, if they would have said, solve for m, then I could back-solve this if I did not know the quadratic. But that's not what they're saying. They're saying, solve for both values of m, add them together, what do you get?
Okay.
And that is not the kind of problem that lends itself to back solving. Because you could have this, in other words, there might be an infinite number of solutions to add together to get the answers. So you can't, problems that lend themselves to back solving are when you can take an answer, plug it in, and immediately tell whether it's correct or not. And you cannot do that here. So we really do have to use the quadratic formula. So what is it? Go ahead and fill it all in for me.
Okay, so I have...
Is there a shortcut we could take? To make the math a little easier? I'm not sure it's worth doing, but it might be. This is non-calculator portion, right?
Yes.
So you're going to have to deal with 16 squared minus 4ac. Notice one thing about that. What can I do to that?
Can't you... Could you factor out a 2 first
Yes.
and then...
Whenever you're looking at all even numbers, you can always factor out a 2.
Okay.
I'm writing it over here after factoring out the 2. And then that's going to make the math a little easier. Because now b squared is 64. I can deal with that. So what do we have? Let's use these coefficients in the upper right here.
Okay, so you have 8 plus or minus the square root of... Hold on, 64.
That's always going to be a positive number. Even if it's negative, it's going to square to be positive. And then I really feel very strongly about having students do this a very specific way. It's so easy to make a mistake here. A is what?
1.
C is what?
4. Positive, positive 4.
Now, what I tell, you can do it any way you want, but what I tell everybody is to do that calculation next.
Yes, find the discriminant.
Well, the discriminant is actually the whole thing.
Oh.
In other words, b squared minus 4ac is the discriminant. But a lot of times when you're actually doing the calculation, you have more than one negative signs. C is often negative, so you'd have a negative sign there in front of that last 4. But the order that you do this calculation, I've seen so many students make mistakes because they tried to do the whole thing at once. They started with the 64 instead of starting with the 4ac.
Okay, I see what you're saying.
That is 16. So it's 64 minus 16. And we're still dividing by 2a, which is that. So now what do we have? We have 8 plus or minus the square root of what?
48.
What is it?
48.
All divided by 2. Now, trying to figure out if we actually need to simplify this in order to come up with the answer. In other words, you don't always need to take a problem to its end, but okay, simplify this for me in blue. What's square root of 48 simplify to?
It simplifies to 4 root 3.
Okay, so we have 8 plus or minus 4 root 3, all divided by 2. Simplify that. Notice you can divide top and bottom by 2.
Yes, so then that would give you... I don't know if I did this correctly, but I think... So when I did that, I got 4 plus 2 root 3.
Plus or minus 2 root 3.
Plus or minus root 3, sorry.
Those are your 2 solutions. Okay. Now, we're not done with the problem. Almost all of these harder problems are like 3 problems in one. It's one thing I like about this practice test over all others is that if you solve a problem, you're learning like 4 different algebraic principles. Okay, so I got 4 plus 2 root 3, and they want the sum So I'm going to add it to 4 minus 2 root 3. What's the answer?
That would just be positive 8.
You got it. Now, feels to me like there should be a shortcut method to get to that answer, but I can't. There is a shortcut. I just realized what it was. First of all, knowing that you have to use the quadratic formula, and knowing that this part of it is always going to cancel it out, right? In other words, that has to cancel, well, not that, yeah, this, excuse me, has to cancel with that by definition.
Oh.
So is all I really have to do is figure out what minus b over 2a is. Right? Let's see, that would be 8 over 2. Ooh, and then you have to double that. So it'd be dangerous to do it that way. But they don't put that answer on there, 4, because it's 4 plus 4. In other words, whatever this part is going to cancel out. So it's b over 2, it's minus b over 2a times 2 is what your answer has to be. I'm not sure it's worth going to all that trouble to know that shortcut. It certainly isn't if you have to do the calculations. But that is a shortcut when they ask you for the sum, because you know these two terms are going to always cancel one another out, because one's a plus, one's a minus.
Yes, makes sense.
Yeah, although, yeah, if they wanted to make that a really tough problem, they would have put plus 4 on there as an answer. And then it would have been a little trickier. All right. 14. Remember your exponentials?
I'd say yes.
Let me write the primary one that you have to know. Yeah, that's not really called y. It's usually called a. Starting amount times 1 plus r to the t. That, oh man, that actually applies, the one I just wrote applies only to annual compounding.
Yes, okay.
And annual compounding is a fake thing that humans invented. It's not found in nature. You won't find anything in nature that compounds annually. Everything in nature compounds continuously, or it decays continuously. So the real formula is this one. Which is for continuous. And yeah, I guess we can use this one. We don't need to use this one up here. I think. Let's see, the initial is a sub 0. So they're asking about how much will be there t years later. So if I use the continuous compounding, it's 325. E, what's R?
Is the rate.
Yeah, which would be minus 0.13 times t. That is actually the correct answer. And the problem they gave you presumes that you don't know that yet, or you haven't been taught that yet. So the problem they gave you really is based on this formula, because I don't see any e's over here. If you don't see any e's over here, then it's not that. In other words, it does not use Euler's constant. So if we're going to have to use that first formula, it's not that much different, and it does fit our model. We start with 325. What is R?
R is 13%.
But it's negative.
Yes, because you're decaying.
Yeah, so it's plus a negative 0.13 because of the decay. And then if you work this out, you get one of their answers. Man, I can't believe they did this, but yeah, you get answer A.
Okay.
I can't believe they did it because it's wrong. Can you give me just 1 second, Izzy?
Yeah.
Be back in 30 seconds, actually.
Okay.
What grade are you in, Izzy?
I'm in 11th grade.
Okay, you've had the E, haven't you? You've had the continuous compounding?
Yes, I have.
Uh-huh. Okay, so you know what I'm talking about.
Yes,
And
I
whenever
do.
you're talking about real things in nature, you're talking about continuous decay or growth.
Mm-hmm.
The only time you're ever going to get annual compounding is if you're talking about money that you take to a bank. And the bank has made up this thing called annual compounding.
Yes.
Maybe it's a bank that decides, well, they're going to pay you and compound it every 3 months, which is a different formula altogether. Or they're going to compound it every day. The best possible compounding is continuous compounding. And the bank could offer that. But that is A equals E to the RT. And that is really what is real in nature, not annual or semi-annual or anything. That was invented by banks only. That's why I'm surprised to see them have that problem on there. Maybe it's intentional. They didn't put the E, so they want you to give the best alternative answer. All right. Number 15.
Is this decomposition of fraction? No, wait, maybe? Yes, your decomposition of fractions. So I don't know if there's an easier way to solve this, but we just learned this in precalculus. So I would start by setting 5x plus 2 over x plus 3 equal to a over x plus 3 plus b over x plus 3.
Okay, what you're talking about is partial fractions.
Yes.
Decompositioning partial fractions, but you always do that when you have a denominator that is the product of something.
Okay.
In other words, if I had the following here, I'm sorry, I didn't turn my writing thing on. I know exactly what you're talking about. I'm surprised you've got it because it's not used until you get to calculus. There is no usage for decomposing partial fractions until you get to integrals in calculus, and then that's the only way to solve them. In other words, if I have 1 over, say, x plus 2 times x plus 3, then you can say that that has to be equal to sum a over x plus 2 plus sum b over x plus 3. and then you can solve it by algebra doing that. But notice that in order for that to use that partial fraction decomposition, I got to have a product in the denominator over there.
Okay, that makes sense.
We don't have that here. So the easiest thing to do is long division. Seriously. And something else that you will have to do in calculus is long division sometimes. It's the only way to proceed on certain integrals. Now, most people, it's probably been 5 or 6 years since you've had to do long division. And you're probably doing it with numbers only. So this may be new to you, doing long division here. And the technique or the method is actually pretty simple. You start by dividing the x into the 5x. What do you get?
Okay, so I get 5.
And then you multiply the 5 by both terms in the divisor.
Okay, so I get 5x plus 15.
And then you subtract, just like you always used to have to do in long division.
Okay, so then I get a negative 17 as the remainder.
Correct. And what that actually means is, well, in most cases we're adding, but we're going to subtract here because it's a minus 17. And what goes under that 17?
X plus 3.
Yeah, so there's our answer right there. D. So it's actually a rather simple problem as long as you know how to divide a polynomial by another polynomial.
Okay.
And as long as you know what to do with that remainder. In other words, because frequently back in the 5th grade, is all you'd have is this, remainder minus 17. But not everybody realizes that you take that remainder and you place it over the divisor, and that the answer is 5 minus 17 over x plus 3. Okay?
All right.
All right, let's take a look at, that's the last of the hard ones for that section. Now, it's worth knowing that when you start another section like the grid in, it starts over with its degree of difficulty. You're back to starting with easy problems at the beginning. Let's talk about these grid-in answers for a little bit. We talked a little bit about it already. Let's look at this one on 2/3. The one answer that is not acceptable is this one. And it's not obvious at all that this would not be acceptable. What happened here? Hold on. Let's first of all do that. You notice down here where it says 201? Either position is correct. I can use the last 3 columns or the first 3.
Okay.
But when I look at this 2/3, 0.666 is correct, 0.667 is correct. What is not correct would be leaving the first column blank and making it 0.66. That would be wrong.
Okay.
In other words, if you're going to have a decimal, do not proceed it with a 0. And one way you can tell that this would be wrong is notice there's no bubble for 0 in that first column. There's no way to put a 0 right there. Because remember, when you take the SAT, They are not reading your numbers. They are machine reading the bubbles. So it would be impossible to grid that in. 0.66, that's four spaces, but there's no place for a 0 in that first spot.
Okay.
Okay? So that's a good way to remember you can't do that. If you're going to put a decimal in there, start the first column with the decimal. Oh, well, that's weird. Oh no, this is still grid in. Sorry.
Okay.
All right, number 16. Now, I just told you that this should be an easy problem, right? Because we're starting a new section.
Yes.
It doesn't look all that easy to me, but maybe it is. So you know you have at least a 250 and at least a 750. You have one of those for sure of each.
Mm-hmm.
There's 3,000 given out. So what's a good next step to do?
So I
In other words, we know we have at least one of those and we have one of those. So let's subtract 1,000 from the 3,000. Now we only have 2,000 to divvy up in any way that we want.
Okay. Okay. So then would you
And there are multiple answers. There is not just one answer here. Notice that it says, what is one possible number of $250 bonuses? Well,
so then you could just divide 2,000 by 250?
well, that would be 8. Yeah, no, you could do that.
Mm-hmm.
So 8 times 250 is all 2,000. So what would one possible number of $2,000 or $250 bonuses awarded be?
It would just be 8.
No, 8 plus 1.
Oh, so it'd be 9.
9. That would be
Oh.
the correct answer. Now, I'm going to show you what I would have done just to point out another way of doing it. I know these add to 1,000, right? So why don't I just double them? Make that 500, make that 1,500. There's my 2,000 right there. In fact, there's my 3,000. And so one possible number of $250 bonuses is 3. To me, that's the quickest way to do it.
Okay.
You weren't wrong. In fact, yours might have been quicker than mine now that I think about it. The only problem with your way was it gave you a bigger number of $250 bonuses. It 8 of them. In other words, so now I had numbers like that, and I've got to figure out how many $250 bonuses I have there. Well, as long as you remember it's 8 plus 1, you're fine, but it's an easy mistake to make by answering 8. because you're dealing with a big number, 2,000. So my method, it's not as probable that you will make that mistake. At least I don't think it is.
Okay, that makes sense.
Because then you can clearly see you have 2 there, plus the 1 you started with, you have 3. I don't know. That's
Okay.
probably a matter of just choice. I like 17. What are we going to do with 17?
You would start, or I would at least start off by distributing the 2x.
Tell me the next line.
Okay, so then I would get...
Do that first.
Okay, so I get 6x squared plus 10x.
Now do that one.
And then I get 9x plus 5.
Plus 15.
Oh, plus 15, sorry.
Okay. But if you've read the problem correctly, now it's easy enough if we combine everything. And if that's equal to ax squared plus bx plus c, we know what a, b, and c are, right?
Yes.
But it really only asks for b.
Mm-hmm.
And I know b is always the coefficient of that middle term. And I know when I multiply or when I'm solving that, I really don't care about that. I don't care about that. The only thing I care about is that right there.
Okay.
So you know you're going to have to add those two together. Whatever the coefficient is, that's b. And that was that was not terribly hard. In fact, both of those first two problems were probably easier than they looked. And you might know that because they came at the beginning. In other words, it'd be easy to look at this one, number 16, and say, wow, that's a hard problem. I'm going to put a double check mark by it and come back to it later.
Yeah.
But in reality, it was really an easy problem, as was 17. So it is useful to know whether you're looking at hard or medium or easy problems. If I looked at this problem and it was the last problem of the test or the grid end, I might be inclined to think it was harder than it was. Okay, let's look at 18. So the main, here, I gotta do this again, sorry. And feel free to holler if I accidentally take you over time. I need to move my clock so that it's in front of me when I'm doing this, because unfortunately when I use my drawing tablet, this time I see down here in the lower right hand part of my screen doesn't change. So, I mean, as long as I'm on this page, that's going to say 451.
Okay.
Okay, so let's see. We got AE parallel to CD. We could almost predict that without even reading it. What is the length of CE from there to there?
Okay.
Tell me how you're going to solve this conceptually. What kind of triangles do we have?
You have scaling triangles?
No, what I meant was in relationship to one another.
Oh, would they be similar triangles?
Yeah, they're not congruent. Clearly, one is bigger than the other.
Uh-huh.
but they're similar. Why are they similar? Because that angle is a vertical angle.
Yeah.
Those are the same. Because they're parallel lines, that angle is the same as that. They're alternate interior. And if two angles are the same, the third one has to be the same.
Mm-hmm.
In other words, D has to be the same as A. So I'm looking at two similar triangles. And what do we know about similar triangles in terms of their proportions?
That you can put the value or the length of.
So give me a proportion that I can work out.
Okay, so I have 5/10, and it's
Those
equal to.
are two, those are the corresponding sides of those two similar triangles.
Uh-huh.
5 is not the corresponding side of the 8 because
Yeah.
of the parallel lines.
Uh-huh.
BD is the corresponding side to AB. So 5/10 is the right ratio. For the moment, let's solve for CB. What would CB be?
4.
Correct. So CB is 4, but they didn't ask for CB, they asked for CE.
So then you would add 4 to 8 and get 12.
Perfect. Now, I should add one other thing. On the ACT test, there are almost an equal amount of algebra to geometry. On the SAT test, algebra is there's 4 times as many algebra problems as there are geometry. Okay?
Okay.
So geometry is not as important on the SAT test as algebra is. All right, let's go down. No, now we're going to get some fairly hard ones. This looks like a trig one, number 19. Are you taking trig this semester?
No, I took that last year.
Okay, but you've had it. You've had a full
Yeah.
semester of trig?
Mm-hmm.
Okay. So this angle they're telling us is pi over a radians. What is the value of a?
Okay.
First of all, let's just take that out of there for a moment because I think it's actually easier to do this problem if we approach it a different way. If this were the unit circle,
Uh-huh.
that was a 1. What is that and what is that in terms of trig functions?
Are they, so your x coordinate is the length,
It's the cosine
the cosine.
angle,
Oh, okay.
and the y coordinate is the sine of the angle. Okay?
Okay.
And they told us the angle is pi over a. It's not helpful that I called this the unit circle. For one thing, it is not a unit circle, and we know that because the sine is equal to 1.
Yes.
Okay. For the moment, let's just call that angle x. What do we know? Besides the x-coordinate is cosine and the y-coordinate is sine, what about tangent?
So then the tangent is the sine over cosine.
And the sine is 1, cosine is root 3. Correct?
Yes.
Okay. Now if we go back and we look at our special triangle that has a root 3 in it, it's the 30/60.
Mm-hmm.
There's a 1, a root 3, and a 2. Which angle are we looking at? What angle is x? In other words, x is going to be the inverse tangent of 1 over root 3.
So you would be looking at the 30-degree angle.
Yeah. So we know, based on these coordinates right here, that angle's 30 degrees. And they're also telling us that 30 degrees equals pi over a.
And that would mean a equals 6.
Correct. Perfect. Because you know pi equals 180 degrees.
Okay.
And I think that's probably the easiest way to solve it. And that is a tough problem. Because, first of all, not everybody knows that that's the cosine of x or that that's the sine of x. And you don't even really need to know that. What you really need to know is that the sine over the cosine is 1 over root 3, which fits that special triangle right there.
Mm-hmm.
In other words, you have worked with this triangle probably for 3 years.
Yeah.
And even though you took trig last year, you should remember that one of those angles has a tangent of 1 over root 3.
Mm-hmm.
And since tangent is sine over cosine, we know that that has to be a 30-degree angle. And once we get that far in determining that that's 30, then the rest of it, and you still have to know your conversion between degrees and radians, which you knew just fine. So, yeah, no, I'm impressed with your skills, Izzy. I am. You should do well on this test. We haven't worked together enough that I could remember that you were this good. But you've handled everything that we've done so far.
Awesome. Well, thank you.
Yeah. No, you should feel confident going into this thing. But anyway, I will let you go. I've run you over your time. And I will talk to you next time.
Okay, sounds good. Thank you. Bye.